Hi everybody, this is lesson 5.2. We'll continue looking at linear models in this lesson. So let's read the specific objectives. Students will understand that linear models are appropriate when there's a situation with constant increase or decrease. Slope is the rate of change. Slope has units in context. Different representation of linear model can be used interchangeably. Students will be able to label units on variables used in linear model, make a linear model when given data or information in context, make a graphical representation of linear model, make a table of values based on linear relationship, and identify and interpret the vertical and horizontal intercepts in context. Alrighty, so we saw linear models last time. The defining feature of the linear model, which I want to remind you, has the following form. It has some kind of dependent variable. Then we have some starting value. And then it's plus rate multiplied by some other variable. So the other day, during the first lesson, we saw how commission salary depends on the amount of sales being made. The more commissions were sold, the more salary Edgar was getting. The other model we saw was the Metro card. The more rides you take, the less of a balance you have remaining on a card. So we're going to continue with this idea, specifically looking at the rate of change and trying to understand how it is the most deterministic part of linear relationship. Okay, so we're going to look at the problem situation number 1, maximizing business revenue. A home business manufactures custom-made necklaces. They conducted market research survey and found that 200 necklaces are sold each week if the price per necklace is $12. If the price is lower to $10, then more necklaces can be sold, 300. Okay, so we would like to know after this survey, what is the better price from the business standpoint? Is it $12 per necklace and then you have 200 of them being sold, or it's $10 per necklace and then have 300 being sold? I'll give you a moment. All right, so you want to collect more money, right? From the business perspective. There are many variables that go into this, which we'll discuss in this lesson. But one thing that we can say is, well, where do we collect more revenue? So let's define the word revenue. And these are the dollars collected from customer, right? So where do you get more money? Well, $12 multiplied by 200 will give you a revenue equals to $2,400, while if you have 300 necklaces at $10, you collect $3,000. Let's write that down in more comprehensive way. So we have revenue equals to number of necklaces, number sold, let's just write it like this, number sold, multiplied by the price per each, correct? So from the first one we got 200 times 12 per each one, so that gives us $2,400, while the other one we got 300 at $10 each, which gives us $3,000. There are other considerations that are there, but for now we would like to investigate that relationship, which makes sense from a business perspective, right? When you decrease the price, you can sell more. But then you also want to realize the other factors. Can you name some other factors that you also have to consider? I'll give you a moment. Yeah, the other variables that you want to consider is the cost to you, right? I mean, how much would it be to produce these items? Because, you can sell them for 1 cent and you'll get millions of them sold. But then to make those million necklaces, it will cost you much more than 1 cent. You understand? So there are more things to consider. So let's go on with this. So first, in order to understand this better, the business owner wonders if another price would be better to produce even more revenue. So she decides to create a linear model there. to determine what would be the price for a different number of necklaces that could be sold. So she defines the following variables. N is the number of necklaces sold, and P is the price of the necklaces. Now let's read carefully the setup of the question 2. It says, let P be the variable on the horizontal axis and N be the variable on the vertical axis. Design a graph below with the appropriate scales for the two variables and plot the above data obtained from the market research. All right, so the definition of what variable is what is important. So we have N, well, it's already here. We have the N and we have the P. Let me ask you a question. Does the price determine the number of, well, let me ask you this way. What depends on what? Does the price depend on the number of necklaces being sold, or the number of necklaces depends on the price? Okay, so which variable here is the independent and which variable here is dependent? What depends on what? I'll give you a moment just to give me an idea of what do you feel. All right, so in this setup, the variable that we call independent is the price. So you're going to set the price, and based on the price, you will be able to determine the number of necklaces that are sold. So N is going to be your dependent variable, while this one is going to be independent. All right, so to make a connection with what you know from study of a little bit of algebra and seeing the variables, the price is your X and the N is your Y. So you give me the price and I'll give you the number of necklaces being sold. That's what we are asked to do, because they told us put the P on the horizontal axis. The horizontal axis is the X-axis, is the one that's here. That's what they ask us to do. So this is our X. We don't use the variable X, we use the variable P, so let's not get lost with that, it's okay. While N is going to be the number of necklaces, so that serves as our kind of like a Y. So that's number of necklaces. And it's capital N. Alrighty, so let me go ahead and just for convenience, so we can then graph this nicely, put the numbers here, and then I'll give you a moment to plot it. All right, so the price is if we read the question, so it says that if the price is $12, then you can get 200 sold. I'm also hoping you print your lessons from Blackboard so you can reference them instead of just looking at the screen, and maybe go along with me or write whatever you have in your notebook. But here we go. We got the price is 12 and the number of necklaces is 200, and then when price is 10, we can sell more, 300. So we're going to go ahead and decide of how we're going to graph this. Okay, so I want to give you a moment and I'll ask you, what should you use as a scale for the price? Okay, so how much you want to move by? Again, there are about 25 divisions here, 25 cells. So I'll give you a moment. All right, so I would go either by $1 each division, or I'll skip one and I'll go by $1 every 2 cells. Okay, the more spread out I make, the better it would be. So I can do $1, $2, and so on. Okay. Actually, I reconsidered. Let's go by $1 each division, because that way we'll have more space left. All right, so these are the money, how much we'll set the price to, and then we got to split. We got $300, but you can go higher, so we want to kind of spread it out nicely. Let's decide on a scale. I'll give you a moment. All right, so you can go by $50. Maybe $100 would be a little bit too big, so yeah, I'll go by 50s. So 50. If you did 25, that's also okay. Again, it's all relative. So I'll go by 50. So 50, 100, 150, 200, and so on. Alrighty, so these are the number of necklaces being sold. Now let's go ahead and plot each of them. So it's $12 and 200. So $12 and 200. And then $10 is 300. Alright, now what is she trying to do? Design a graph below with appropriate scale and plot the above data obtained from the market research. Okay, so let's connect them then, right? So let's go ahead and connect them. I'm going to use the ruler. Alright, so I'm going to connect them. I shouldn't just stop there, right? I shouldn't stop just at those 2 points. So I'm just going to go ahead and go all the way from the beginning and all the way at the end. Because, you know, when we discuss the linear model, it would be useful to describe all of its features. All right, so here's what we got. We got this linear model, and it says, according to the graph, what is the predicted number of necklaces that are sold for a price of $8? Okay, I'll give you a moment to look at the chart and decide what would be the number of necklaces sold if you go by $8. So look at the graph. Okay, so if I use this ruler just for you to see it better, all right, so right here at $8, I'll use a red dot to plot it. Okay, so at $8 we got, let me move this right here, it looks like it is about 400, correct? All right, so it's 400. Now it's asking you, so what would be the revenue? So if you sell 400 at a price of $8, what would be the revenue? Go ahead. All right, so that would be $3,200, which is more than what we had before, right? From 10 it was 3,000, so 8 is even more revenue. We can even write those numbers right here. So we got the revenue here, 3,200. We got revenue right here that was so 10, so 3,000, and then at the 12 it was 2,400. All right, so these are our revenues. So we just multiply price by the number of necklaces sold. So the question is, decide what price would result in the most revenue. So does that pattern continue? What would it be? So try it out. And I encourage that you not just use the ones that we're given. Try the other combination and see what's going on. You can even use this chart and just multiply the price times the revenue and see what would be the better deal. All right, so I'll give you a moment to try out different numbers. Go ahead. All right, so if we use, let's say, $6, so $6 gives us 500, so it's back to 3,000. Look at this, interesting. So the revenue is actually decreasing as you are selling more units at the lower price, so it seems to be coming down. If we try another one, let's say 4, it goes back to 2,400. So it's actually giving us a little symmetry, right? So it goes the other way, and it appears to be that this price is actually the best deal in terms of the revenue, 3,200. All right, that's when we sell it for $8 a piece. So one thing just to keep in mind before we finish this part of the this problem situation. So 3,200 gives you the most money, but what you also have to consider is that you're selling it for $8. So you would need to know how much it costs you to make those necklaces. So the assumption is that it will cost the person less than $8 to make it. Otherwise, you wouldn't be getting profit. Okay. So, but in terms of collecting the dollar amount from selling them at $8 a piece would be the best deal. Okay. So the best outcome in this situation. All right. So here we go. So what would be the price? I guess this would be the best, right? So $8. Okay. So here we go. So that's based on that. Alrighty. So what else we asked to do? Oh, we asked to now actually write the mathematical to describe this as a model. So question number 6 is asking you to find the slope of the linear model and explain the meaning of this in the context. So look, so we're gonna do a table, right? I'm just gonna put the numbers that we got so far. So we were giving 12, and where were we going? We were going down, right? So we got 12, and we got 200 necklaces, 10, 300 necklaces, 8 we did, right? So that was 400 necklaces. What else we did? I mean, do you see the pattern right now? Can you see what the pattern is? I'll give you a moment. All right, so it looks like as the price goes down by $2, you're able to sell 100 more necklaces. So as the price goes down by $2, you're able to sell 100 more necklaces. Now notice that even if you go to $9, so you don't have to step by, let's say, by even numbers. So if you do 9, let's say, we're able to sell 350 from the chart. So that doesn't violate it, right? So the 9 would be located in between, and that will be exactly half of 100. All right. If you go this direction, let's say what goes 8. So the next one will be 7. Let's say 7 price. At the price of 7, we're getting 450. So it doesn't break the pattern. For a $1 increase, it goes down by $50. You can, I mean, it goes up by 50, not by $50, but by 50 more necklaces. So if we write it as a slope, all right, the slope is, remember you learned this in algebra, rise over run. So in this case, is the change in the dependent variable over the independent variable. So it is change in n divided by change in p. The delta represents the change. So it's n2 minus n1 over p2 minus p1, or if you remember, y2 minus y1 over x2 minus x1. What you're doing is you're basically subtracting the dependent coordinate and then dividing it by the independent coordinate. All right, so it's dividing the change in this variable by the change in this variable. Okay, so that would be 100 over minus 2. So, and this is dollars. So it's 50 necklaces. Oh, it's minus 50 necklaces for every dollar increase in price. All right. So if we go and look at the picture right here, then you can describe this as a staircase. You see, you're moving 50 items, $1, 50 items, $1, 50 item, $1, or you can jump all the way from, let's say, here to here. It goes down 100 for every $2 increase. 100 necklaces for every $2 increase in price. You see? So that's the characteristic of a linear model, that it has a constant rate of change. She made it linear. All right, it says assume you have a linear relationship, so we connect it with the line. So we made that a linear model. It says find the vertical intercept of the graph and use it with the answer to the previous model to construct a linear model. So you see here, I gave you the complete picture. That's why the reason why I wanted the scale to go all the way out. So that number, the vertical intercept, can you identify it? What's the vertical intercept of this model? I'll give you a moment. All right, so looking at the diagram, the vertical intercept is right here. It's 800. What does it mean in the context of that question? Well, if you're selling for free, then you are able to sell 800 units. Of course, it doesn't look reasonable. If you're giving something for free, everybody will take it if they want it. So if it's something they're interested in. So, you know, the answer wouldn't be 800. So 800 in this case is more as an anchor, kind of like to make our model the way it is. The model itself might not be reasonable over there, but when you are around somewhere inside of that model, then it makes sense. Model is trying to model the reality, so it doesn't need to represent the reality 100%. So as you go all the way down, you know, it might not be as reasonable. Okay, so so that's the vertical intercept. So vertical intercept, according to the graph, is at the $0, you're gonna sell 800 necklaces. And then writing the equation, if you remember, has the form y equal to mx plus b. That's how we learn it in algebra. And in this class, we say y equals to starting value plus rate multiplied by the variable that is independent in this case. So here, don't get confused, okay? This is the variable we're analyzing, how many necklaces we can sold. So it start off at 800 necklaces, and then the price, not the price, but the number of necklaces declines $50 for every necklace that you sell. So the model itself is like this, and instead of x, we actually use the p. You see, the starting value minus 50 multiplied by p. So that is our equation. Let me also ask you one more thing here. Do you see a horizontal intercept? Does this graph have a horizontal intercept? The lesson didn't ask for that, but I feel like we should mention it. Yes, there is a horizontal intercept, is $16. So at the price of $16, nobody is going to buy those necklaces because you see, according to this model, it falls all the way to the 0. Notice if we write the model like this, n equals to 800 minus 50p, all right, the horizontal intercept actually represents the place where your model becomes 0. All right, you see that point, this right here, has a y coordinate, which is that n coordinate equal to 0. So if you solve for p, all right, so basically, what's the price that no one is going to buy these necklaces? Well, if you solve this equation, you can move 800 on the other side. Divide both sides by 50. And then notice what we're getting. We get a price of, well, negative 50 is $16. And you can see visually, at $16, no one is going to buy those necklaces. Which kind of makes sense, right? It kind of makes sense. Well, maybe, there's still somebody who will be interested, but according to this model, it's going to be 0. All right, so we're done with the first problem situation, and we have one more also related to this. Okay, so now we're going to bring an idea of a more realistic situation where we're also going to encounter cost associated in running a business. All right, so in business, the money a company spends is called cost. We didn't consider cost in the other lesson, in the other problem situation, but we'll consider it now. And money the business takes in is called a revenue. We talked about the revenue before. It's the money that you get from a customer. Generally, the business needs to sell enough goods to make up for the cost, and the number of goods needed to make up for the cost is called a break-even point. So let's investigate this a little bit more. Consider a small business selling hand-designed dresses made in a small lot building. The rent on the lot is $1,200 per month. There are 2 employees, each of whom are paid $20 an hour, 8-hour days, 5 days a week, and each dress is then sold for, oh, actually not sold, it says each dress costs $40 to make. All right, so it's cost $40 to make. To mathematically analyze the business cost, a model can be created. Define the variable that will go in the model for the cost. Okay, so what would cost depend on in this case? All right, so what would be the cost depend on? So let me give you a moment to say what the cost associated with this problem situation. All right, so there are 2 things that we have. We have what we call a fixed cost. All right, so in this case, we're talking about fixed monthly cost. All of this is monthly. All right, we're going to only talk about monthly cost. So the fixed cost includes rent and the salary. So that's fixed. It's not going to vary. It's just whatever you pay. You got to pay your employees and you got to pay for rent. So that's fixed. Sometimes it's called an overhead cost. And then the other thing, which is dependent, is the number of dresses sold. Dress is not sold, dress is made. And that's going to be a variable cost. Okay, so it's a variable cost because depending on how many will be made, it costs $40 to make one, so it's a variable cost. So therefore, we need to define a variable. So we're going to call that an X. All right, so create a mathematical model for the approximate business cost. So to help you with that, I want you to first, let's break this down. I want you to calculate the fixed cost. So the first question I want to ask you is how much would be the salaries for the two people? Salary for both of them. All right, so use the information that I'll highlight right now, and I want you to tell me how much would you have to pay those employees, assuming that there are 4 weeks in a month. All right, so just 4 weeks. We're gonna pay bi-weekly basically. So salary is going to be monthly for these for the two employees. Okay, I'll give you a moment. All right, so let's calculate this. So we got two people. Well, let's start with the dollars. So we got $20 an hour. They are working 8-hour days. They're working 5 days a week. And they're working for 4 weeks in 1 month. And there are two of them. All right, so let's grab a calculator and let's multiply. You see the bottom is only all ones, so we just need to multiply these numbers on a calculator. Give you a moment. So we're getting $6,400. And now we need to add the rent, which is $1,200. So that will give us a total of $7,600 as our kind of like overhead. Okay, so this is the amount of money you have to pay in order to, have people working for you. The next thing is the variable cost, right? The variable cost right here is not fixed, it's X. All right, so the variable cost, the way you would represent it, so this is the fixed cost. So the variable cost, I'll write it right here, is going to be $40 for every dress. But it's not one dress, it's not two dresses, it's three. You see, it depends. So that's what mathematical model helps us to define. We can express that as an equation. So we'd say it's $40 multiplied by X for each dress. Okay, so now our model becomes, our cost model is a starting value, which is $7,600 that you pay for everything, and plus another $40 per dress. So these are the cash that you will have to spend each month. It will depend, I want to emphasize this, it depends on how many dresses you make. All right, of course, the more you make, and if there's a demand, then you can sell more, and then potentially then make some profit. What kind of mathematical model is this? Well, we haven't seen any other models yet, so this is a linear model. All right, it decided that you will be selling each dress for $80. Create a mathematical model for this business revenue. Okay, so what would be the revenue if you sell each one for $80? Again, keep in mind that the X dresses are being sold. X is the variable here, so the revenue is also depends on the number of dresses you sell, keeping X to be that same variable. So I'll give you a moment. How would the revenue equation look like? All right, so the revenue equation will be just 80X. You sell 10 dresses, you get $800. You sell 100 dresses, so that would be $800 or $8,000, and so on. All right, and now the last question in this lesson is now use the models created to find a break-even point, the number of units that must be sold to break even. So the break even means that the revenue, the money that you get in, right, that you put in, has to be equal to the cost to you. So the revenue has to be equal to the cost. The amount that you spend should be equal to the amount of money that you collect. When these two are equal, you break even. And then from that point, you're going to be, getting more and more money. All right. So let me ask you how the equation would look like. All right. So select a choice. All right. So look at this and look at that and make them equal to each other. Select the choice. All right. So here's how it's going to look like. It's 7,600 plus 40x would be equal to 80x. This is going to be the equation to be solved. All right, I'm going to copy it for you here. Actually, you see it's written this way, revenue and the cost. It's the same thing. It's exactly the same thing. It's still an equation. And I want to give you a moment to try solving it. Okay, so try to do your best to see what the x equals to. All right, so let's review it. To solve the equation, this is the first time where we see a linear equation where the variable is on both sides. So the way we're going to go, we're going to subtract 40x on both sides, because equation is just like a scale. Whatever you do on one side, you're going to do it on the other. By the way, this makes sense. Look, you see this equation makes sense. If it costs you $40 to make a dress and you sell it for $80, that means your profit from each dress is $40, right? The difference. But then you have to pay everybody and also pay for rent. That means that you have to break even. You want to make sure you sell enough to cover all your costs. That way you're making $0. You didn't make any money yet, but you are able to pay your employees and the rent. So how many dresses would that be? So let's go ahead and divide. 190 dresses. And just be careful. If you sell less than 190, then you are in debt. You're going to have losses. But if you sell more than 190, every additional dress that you sell is going to give you $40 extra. Just to show you that those are equal, check out the revenue. So 80 dresses, $80, you sold 190 dresses. That gave you a revenue of, let's multiply, 80 times 190. So you collected from your customer, you collected $15,200. A lot of money you got from your customer in that 1 month, but at the same time, your cost was $40 to make those dresses, plus $7,600 to pay your people working for you, and the rent, and that's also $15,200. Okay, so what's your profit? How much money are you actually pocketing? $0. Okay, so you have a lot of cash circulating, but you're not making any profit yet if you only can sell 190. So here goes a little introduction to business. Okay, on that, we're going to finish the lesson.